Okay, so we've determined that with this Internet of Things concept that's growing along with the hardware and the software and its ability to communicate from device to device and to share information autonomously is all happening in front of our face. How are we going to secure this thing? Remember, we're talking about the opportunity to use this technology in factories, in healthcare, in transportation, in arenas that could hurt us if something goes wrong. So IoT security methods are going to vary depending on the specific IoT applications and the place that you're deploying these IoT systems. Different places in the world, different infrastructure, different manufacturing categories. So for instance, IoT manufacturers, from product makers to semiconductor companies, are going to want to concentrate on building security of the physical system, making hardware tamper-proof, whereas those application developers are going to want to focus on using best practices for software development, developing ways that they're able to test their processes against known vulnerabilities. So let's look at a few of the best practices that already exist for securing IoT and IoT devices. The first is incorporating security at the design phase. IoT developers should include security at the start of any consumer development. Enabling security by default is critical, as well as providing the most recent operating system and using secure hardware. Hard-coded credentials should never be a part of the design process. An additional measure developers can take may require them to change credentials of people working on the development every couple of months. If the device comes with default credentials, users should have to update those credentials to provide a strong password or multi-factor authentication or even biometrics. The next area is PKI, or digital security. Public key infrastructure, PKI, and these digital certificates play a very important role in the development and securing IoT. Remember, devices will be talking to each other. And if these devices are talking to each other, they have to authenticate, or they have to say to each other, "Hi, I'm Mike. Here is my access code." And that other device has to recognize it and accept it. So, a critical role in the development of secure in these IoT devices is providing the trust and control needed to distribute and identify the public encryption anomalous activities, where actions can be taken should an issue be detected. So whereas these devices are taking automatic action, well, if they detect that something is not right within its own self, it needs to also be able to take an action. The next one is security gateways, acting as an intermediary between the IoT devices and the network security gateways. There has to be processes to look at the power, the memory, the capabilities of the IoT devices themselves, which provide the ability to implement features such as firewalls to ensure hackers cannot access the IoT devices they connect. Patch management, or continuous software updates. This provides a means of updating devices and software either over autonomous or automated system, or by someone going up to it and physically updating the system. Having a coordinated disclosure of vulnerabilities is important, because once we know those vulnerabilities, we know that we need to make a patch or update that system to close that vulnerability. IoT and operational system security are new to many existing security teams. So it's critical to keep security staff up to date on new issues and emerging threats, such as secure data exchange or network vulnerabilities of a particular software, or issues like verifying identity. API security is the next one. Application Performance Indicator. That's an API. API security is essential to protect the identity and integrity of the data being sent from one IoT device to the other, and to ensure that the authorized devices or developers or apps actually are communicating with APIs and not some hacker. Identity management, very important. Providing each device with a unique identifier is critical to understanding what the device is, how it behaves, so that when the other devices interact with it, if something is wrong, those other devices also recognize that there is an issue. Hardware security. We talked about making devices tamper-proof. Endpoint hardening includes making devices tamper-proof and tamper-evident. So if someone has been fooling with or trying to access the device's internal components, you will have a way of knowing that. This is especially important when devices will be used in harsh environments or where they may not be close to where humans are, like out in the wilderness, out in the mountains, in small towns and remote places. And strong encryption is critical to securing communications between those devices as we discussed. Data at rest and in transit should be secured using cryptographic algorithms. This includes the use of key lifecycle management. Now, the next opportunity for us to secure these devices is network security. Protecting an IoT's network includes ensuring port security, disabling ports forwarding, and never opening ports when they don't need to be, using anti-malware, firewalls, and intrusion detection systems are also critical. The next one, network access control. So as you can see, there are a lot of things that can be done, but you have to have teams and systems in place to actually do this stuff. So in the network access controls, the NAC, they help identify and inventory IoT devices connected to the network. This provides a baseline for tracking and monitoring devices. IoT devices that need to be connected directly to the internet should be segmented into their own network and have access to enterprise network restrictions, meaning that they should not be able to, on one side, connect to the internet and then on the other side have access to all of your devices. Because if a hacker comes across the internet, connects to that device, they now can control your network. IoT devices that need to be connected directly to the internet should also be monitored. Okay? So the last one is your integrated teams. There are people who are experts in hardware, there are people who are experts in software, there are people who do the project management and who may demand that an action is taken based on their job responsibilities. It is critical that these people are working together so that they don't create a seam in your security system. Along with training, integrating disparate and regularly sliced teams can be useful. For example, having program developers talk to the hardware experts will ensure that the proper controls are added to devices during the development phases of the network. And then lastly, consumer education. Consumers must be made aware of the dangers of IoT systems and provided steps that they can take should something go wrong. For instance, when people are buying devices like those video doorbells, those Ring doorbell systems, some of those people are unaware that the default passwords are the same for all of the devices. Thus, a hacker who has knowledge of what the default passwords are has a very easy time of accessing that system and then taking control of it. And all of this is done without the consumer's knowledge. Lastly, we need to look at security from a global point of view. And there are organizations across the world, experts who are working together to develop IoT security frameworks and approaches that we can all take no matter what your skill level is. We'll see you in the next class. Thanks for joining me.